Okay, so let's do practice quiz 5. So we're given test 1 scores, test 2 scores, and final exam scores. That's our data set. We have to answer some questions. So the first one is to create a multilinear regression model that predicts final exam scores based on test 1 and test 2 scores. So we're pretty much looking for a model where we have final equals sum A times T1 plus sum B times T2 plus sum C. Need to minimize the RSE. So we're looking for A, B, and C that minimize the residual standard error. So in R, how we'll do that, first we need to get R to read. So let's do the R code here. So let's first get R to read our data set above. So I'm going to call it scores. Call it scores here. And it's going to be defined to be, you need to use something called data frame when you're getting R to read a data set. And then we'll put our different values here. So it'll be in quotation marks, our test 1 column, our test 1 vector. So our test 1 vector, if you go up there and look at the scores, 78, 67, and so forth. So 78, 67, and you can check the rest will be 92, 85, 69, and 56. That's that one done. Then a comma. Then our test 2 scores will go next. So going up here, you'll see it starts at 86, 65, and so forth. 86, 65, and then the other ones are 89. You can check. 89, 85, 75, and 62. And then our final exam scores. So going up here, you'll see there are 82, 72, and so forth. 82, 72. Then you can check the other ones are 90, 82, 72, and 60. Then close this. So that's getting R to read our scores. Now I want R to read the test 1 scores only. So I'm going to have to write like this. So it'll be scores. So like it's telling R to look at the scores data set that I've just defined and take the test 1 vector or column in the scores. And then I'll do the same for test 2. So it's saying look at the scores data set. The $ means take the test 2 column and then the final. So scores $, look at the final exam scores. Okay, now let's create our linear model. So pretty much we're going to look for the linear model will tell us what the A is, the B is, and the C is. Okay, so the one that minimizes the RSE. Okay, so let's call it M1 for our model. And the way we create the linear model in R is we use LM for linear model, and then parenthesis. So we're trying to predict the final, then tilde. We're using T1 and we're using T2. And then to say what data you're using, our data we're using is called scores. This creates a linear model, so this creates the linear regression model. Okay, and now let's do summary. That's going to give us the summary of our model. Will tell us what will give us lots of things, but it'll tell us what the RSE is. It'll tell us what the A, B, and C are up here. will also tell us what the adjusted R squared is. I'll explain what that is in a second. Let's keep going. Now, the question also says to plot the residuals. Let's see, well, predict space, okay, gives a summary of, yeah, plots residuals here, that part right there. So to plot the residuals, when I write below here, just plot, then our scores, then $sign residuals. So residuals, that will plot the residuals. And the last thing I'm going to do is, we want to predict, let's go up here, so I'll say predicted. So we're trying to predict the final exam score of a student who received 74 on test 1 and 81 on test 2. So just take those, copy them, put that here. Actually, this needs to be in quotation marks. Okay, then in the quotation mark. Okay, so then to get R to predict, we just write predict, then we're using our M1 model, then data.frame, then we're using our test 1 score is 74 and our test 2 score is 81. So this should be everything that here. This should answer all the questions then, A, B, and C. So let's run this R code so you can see. So we'll take it here. Let's go to R, have it open right here. Let's go to the top. Get rid of this, paste. Let's see if it runs. Error, okay, so let's see. Oh, it looks like, not quite sure. Let's see. We can go through each one. Let's see. Let's start turning off. Let's turn this off. Actually, it looks like that might be. So to turn off, you put a pound sign. See if it runs now. Okay, turn this one off. Turn this one off. Turn this one off. So that's how you can debug your programs. So let's run this now. Okay, that worked. So let's start slowly turning on stuff now. Let's see if I add that one, what happens. Okay, that's fine too. Let's see if I add this one. That's fine too. Add this one. That's fine too. Add this one. Error, okay, so I didn't like that. So plot residuals. So let's see here. M1. Oh, sorry, I messed up here. It shouldn't be scores, it should be M1 here. So actually go back, let's fix that over here. Should be M1 here. Let's go back over here and run it now. So everything should work now actually now. That was my mistake, it looks like. Okay, yeah, it's running now. So let's go down here. It has information there and it has our residuals graphed on here. Let's take the output here and copy it to the bottom of our R code here so we can interpret. Okay, so to find the A, B, and C values, they're right here. This would be the A value. So if I go up, that'd be the A value right here. And going down, oops, too far. This would be the B value. B value. And the C value. The C value, oh, it'd be this guy here. So that should be the values of the A, B, and C that minimize the RSE. Okay, and we're trying to predict the final exam using 74 and 81 here. So pretty much what it's doing then would be putting 74 here for test 1 and be putting 81 for test 2. Then you can work that out and it'll give you the final exam score. But if you go down here, it's saying that that final exam score should be 76.47, this guy here. So that should be, this should equal that. You can check that if you want. And then the RSE is 2.556. And the adjusted R squared, right here, adjusted R squared is, let's paste that at the top too, is 0.9412. So the closer this number is to 1, it means your model is pretty good. So if that number gets closer to 0, it means your model is not great. So a number bigger than say 0.8 is pretty good. So this is 0.94, which means that our model that we have is should be pretty good at predicting the final exam scores. Okay, so we're done.